Morning, students. We are starting our next chapter, chapter 8, differentiation. Okay, you have studied in your previous year the same chapter. Okay, some properties and what differentiation means. Okay, so I'm not just defining what is differentiation because Okay, so I'm directly going to the chapter. So you have in class 11 you have studied about differentiation. Okay, some of the results have been recalled for you. How will you differentiate a constant? Okay, that is d by d by dx or d by dy is the differentiation form. Okay, d by dx of that is the differentiation. This is how will you denote differentiation. And if we differentiate a constant, what is the answer? It is 0 always. If we differentiate constant, it is 0. And d by dx of f of x plus c, where f of x is a what it is second degree, third degree, any degrees of x and plus the constant. Okay, so that is d by dx of f of x is f dash of x. Okay, f of x is f dash of x. That is how to you differentiate it. For example, d by dx of x raised to 6 plus 8 is d by dx of x raised to 6 plus d by dx of x raised to 8. D by dx of x raised to 6 plus d by dx of 8. So the answer is d by dx of x raised to 6. So you have to differentiate that. What is the answer? It is 6x raised to 5. That is f dash of x. What is you have to do is, yes, x raised to 6. The differentiation of x raised to 6 is, x raised to any power a. X raised to a is a x a minus 1. X raised to a minus 1. Differentiation of x raised to a is a x raised to a minus 1. So x raised to 6 is 6x raised to 6 minus 1, which is 5. Okay, and that is the general form is given in the next. That is d by dx of x raised to n is n x raised to n minus n. And d by dx of ax plus b the whole raised to n is n into ax plus b the whole raised to n minus 1 into a. Yes, these all have studied in the plus 1, so you have to be known this. Okay, and there is a linear function of x. The whole raised to n is n into that linear function raised to n minus 1 into coefficient of x. Okay, and that is you have to multiply it, the coefficient of x. And some special cases has been there. D by dx of x is 1 into x raised to 1 minus 1, that is 1. So x, the differentiation of x with respect to x is 1. And 1 by x is minus 1 by x square. Okay, and root of x is d by dx of x raised to 1 by 2, which is 1 by 2 x raised to 1 by 2 minus 1, that is 1 by 2 into x raised to minus 1 by 2, that is 1 by 2 root x. So 1 by the differentiation of root x is 1 by 2 root x. Okay, and the common form is given for you. D by dx of x is 1, d by dx of 1 by x is minus 1 by x square, d by dx of root x is 1 by 2 root x, and d by dx of root of a linear equation ax plus b is 1 by 2 root of ax plus b into a, coefficient of a. Okay, and a constant into, that is d by dx of c into f of x. Okay, c into f of x is c into f dash of x. The constant is there, c into f dash of x. Okay, and derivative of trigonometric functions, that also you know. D by dx of sin x is cos x. Cos x is minus sin x. D by dx of tan x is sec square x. And d by dx of cot x is cosec square x. Okay, and d by dx of sec x is sec x tan x, and d by dx of cosec x is minus cosec x cot x. These are the trigonometric functions. And derivative of algebraic functions, okay, that is d by if y is u plus or minus v and u v are functions of x, this functions of x, then dy by dx, the function is y, so we have taken dy by dx is du by dx plus or minus dv by dx. Okay, example is also given. And the general form, if y is a algebraic equation, u plus or minus v plus or minus cw plus or minus etc, u v w, that all is functions of x. Okay, then how will you find it? That is dy by dx is du by dx plus or minus dv by dx plus or minus or dw by dx. Okay, and another example is also given for you. And next is, the fifth one is the differential coefficient of product of two functions. Product of two functions, that is, if y is equal to uv, it is the product. Okay, then u and v are functions of x, then it is the product differentiation. Okay, product rule is there, that is the first u into dv by dx plus v into du by dx, it is the product formula, product rule of differentiation. As if two products has been given for you, which is a function of x, then dy by dx is the first function into derivative of the second plus the second function into the derivative of first. Okay, in that is the product formula, derivative of product of two functions. Okay, and there the second one is d by dx of u v w. Okay, that is the same. Okay, the expansion of the rule is that uv, the product of the first two function into the derivative of the second and third and first function into the derivative of the second plus the second and third function into derivative of the first. That is the rule. Okay, I have to multiply the differential coefficient of each function by the product of the remaining two functions and add up the results. Okay, another example, three functions, x plus 2, 3x plus 5 the whole raised to 4 sin x. Three functions has been there given. So first two function into derivative of the last one plus like that. Okay, yes. And the next rule is the infinite number of finite number of functions, product of finite number of functions, which is the sum of the product obtained as the derivative of a function into product of the remaining functions. Okay, first a derivative of first function, any of the function, and then the product of the remaining function plus till all the functions forming the product have been differentiated. Okay, all the product should be there, and at least the one function should be differentiated. Okay, for example, d by dx of x cube sin x into 2x plus 7 into x minus 9 the whole raised to 8. So this sin x into 2x plus 7 into x minus 9 the whole raised to 8 is the first function, and x cube is the second function here. Okay, so you have to write the first function into the derivative of the second and second function into the derivative of the first. Okay, here has been four functions. Okay, I'm sorry, four functions has been given: x cube, sin x, 2x plus 7, x minus 9 the whole raised to 8. Four functions has been there. It is not four functions. So first into the first three functions has been written, or we can write it any way. Okay, here the last three functions and the derivative of first plus the first function and the last two functions into derivative of the second plus the first two functions and last function derivative of the third plus the first three functions and derivative of the fourth one. That is the way using here. Okay, and the next is the derivative of the quotient of two functions, quotient formula. Okay, y is equal to u by v. This always has been studied in the previous class. Dy by dx is v into du by dx minus u into dy by dv by dx the whole divided by v square. That is denominator into derivative of numerator minus numerator into derivative of the denominator divided by denominator square. It's a quotient formula. Okay, d into n dash minus n into d dash by d square. N and d are denominator and numerator. Okay, and example is given. Okay, these are the fun, and there's the reciprocal rule. You have no 1 by f of x is d by dx of 1 by f of x is minus f dash x by f of x the whole square, which is the reciprocal rule. If a function is in the denominator, a function is in the denominator, then you have to do this minus f dash x, derivative of minus sign, minus in the sign is minus. Okay, then the derivative of the denominator divided by denominator square. Okay, and differentiating from first principle, that means the process of finding the derivative of the differential coefficient of a function f with respect to the independent variable x is differentiation. And if the derivative of obtained by using the definition, which is the differentiating from first principles. Okay, so what is differentiation? It is the process of finding the derivative or the differential coefficient of a function f of x with respect to the independent variable x. That is differentiation. Okay, yes, and the following step you have to be used to, yes, that is put the function to be differentiated equal to y. The process of differentiation is given. You have to let the function as y and let delta x, okay, delta x or delta h be an increment in the value of x, and delta y the corresponding increment in the value of y, so that y plus delta y equal to f of x plus delta x or f of x plus h. That delta x can be written as h. Okay, then subtracting that, dy delta y or dou y, it can be say as dou y, is fx plus delta x minus fx or f of x plus h minus f of x. Okay, that is you have to be divide the both sides by delta x and taking the limit x tends to h or delta x tends to infinity. Okay, you will get, yes, the differentiation as limit dy by dx as, or f of x, f dash of x as limit h tends to infinity f of x plus h by f of x by h. That is the differentiation from the definition. Okay, this is the differentiation from definition or the delta method. Okay, delta method. Delta x or h, that is the increment you have taking for x, and delta y is the increment for y. Then you have to yes, you have to subtract that two equations and then divide it by delta x, and then taking the limit as delta x or h tends to infinity. Okay, then dy by dx can be calculated. Okay, so these are the steps to find find differentiation. Okay, limit h tends to infinity f of x plus h minus f of x by h, which is the important definition. This is the main definition of a differentiation. Okay, yes, and an example an example has been given for you. Okay, here delta x is the increment of x and delta y is the increment of y. Then Yes, delta y plus, sorry, y plus delta y is x plus delta x the whole cube plus 3 into an equation has been given, y is equal to x cube plus 3x square plus 5. So substituting y and delta y and delta x, that increments both sides and dividing that, you will get the answer. And next is the geometrical representation, interpretation of dy by dx. That also, yes, that is the tan psi, which is the slope of the tangent of at p xy. Okay, look at that figure. XY axis has been given for you, and y is equal to f of x has been drawn, and dy by dx is the slope. Okay, the derivative of any function at any point p. Okay, p is a point, and on the curve of its graph. Okay, yes, a curve is given. Okay, and at that curve a point is marked p of xy, coordinate is xy, and that curve's derivative is the tangent of the angle which the tangent to the curve at p with the positive direction of the x-axis. Okay, that is the tangent, slope of the tangent at p of xy. Okay, that is dy by dx, tan psi. Okay, and here a point, an example is given. Okay, y is equal to x cube plus 3x square minus xy 6x minus 10. X cube plus 3x square minus 6x minus 10 is the curve, and you have to find the points, okay, where the gradient or slope is given 3. You have to find the, yes, x and y, you have to find the coordinates, point, that point you have to find out. So dy by dx, y is given, you have to find the derivative, and that derivative is 3 given, that is the slope is 3, then you have to equate that equation to say that 3, then you will get x. Okay, yes, that is the geometrical interpretation. And then some small exercises for you as per that. The first 2-3 properties. Okay, differentiate with respect to x. You have to differentiate these problems with respect to x. And then differentiation of a function or a composite function, that is the chain rule. The chain rule is, if g is differentiable at x, g is a function of x and which is differentiable at x, and f is differentiable at g of x, then the composition f of g is differentiable at x, and f of g, f composition g dash of x is f dash of g of x into g dash of x. Composition function, how will you differentiate a composition function, which is the chain rule? Okay, that is, f is a function of x, g is a function of f, that is g is differentiable at x and f is differentiable at g of x, then the composition f of g is differentiable at x, and f composition g dash x is f dash of g of x into g dash of x. Or g, alternatively, y is f of g of x, and u is g of x, and y is f of u. Okay, what is y? Y is f of g of x, and g of x is the function of x, that is u. Okay, u is f of gx, sorry, f of gx is y and g of x is u. So what is y? F of u. Okay, then what is y is f of u. Then what is the derivative? Dy by dx is yes, dy by du, f of u. So dy by du into du by dx, that is the chain rule. Okay, dy by dx is equal to dy by du into du by dx. Okay, derivative of y with respect to u into derivative of u with respect to x, because u is the function of x and y is a function of u. I think it is clear. Okay, this is the chain rule for composite function. Okay, yes, many problems has been given be there. Using chain rule you have to differentiate. Okay, yes, and there is an example. Differentiate sine of fx square, 5x square minus 3x plus 4 with respect to x. That is, you have to put that sine of that bracket function as u. Okay, then y is equal to sine u. F of u, y is equal to f of u, function of u, that is sine of u. Then what is dy by dx? Yes, derivative of y with respect to u and into derivative of u with respect to x. That is dy by du into du by dx. That is dy by du of sine u into d by dx of 5x square minus 3x plus 4. Okay, that is cos u into 10x minus 3. That is cos of, what is u? Substituting u, that is 5x square minus 3x plus 4 into 10x minus 3. Then 10x minus 3 into, after that you have to substitute u. That is the only thing. Okay, yes. Next is chain rule with powers of a function. When what will you do when power is given? If y is equal to u raised to n, which is a function of x, then dy by dx is dy by du into du by dx. That is the chain rule. And when if du is u raised to y is u raised to n, is the power of n. That is what is the power of n, that is n into u raised to n minus 1. That is d by du of u raised to n is n into u raised to n minus 1 into du by dx. Okay, that is the coefficient of x is a power of n, then n into function the whole raised to n minus 1 into differentiation coefficient of the function with respect to x. Okay, and examples are given. Yes. Next is the derivative of absolute value function is a modulus function is given, absolute value function. That is, by definition y is equal to modulus of x is root of x square. Because modulus of x is modulus of any function has two values, root x also has two values. Okay, that is root of x square. It is not root of x square has also two values. So with respect to x, if we differentiate, then we get dy by dx as 1 by 2 x square the whole raised to minus 1 by 2 into. How will you get this? Yes, because x square can be, root of x square can be written as x square the whole raised to 1 by 2. So you have to differentiate it. That is 1 by 2 into x square the whole raised to 1 by 2 into. Then what you have to do is, yes, derivative of x square has to be found out. So dy by dx of, d by dx of x square. That is 1 by 2 into root of x square into 2x. That is root of that is x square the whole raised to minus 1 by 2 is 1 by 2 1 by root of x square. Then that is 1 by 2 is also there. So 1 by 2 root of x square into 2x. X square, the derivative of x square is 2 into x raised to 2 minus 1, that is 2x. Then 2 to cancelled, x by root of x square, that is x by modulus of x. So the derivative of a absolute function is always the absolute function is d by dx of modulus of x is x by modulus of x. That when x not equal to 0, x should not be equal to 0. Okay, this is the absolute function derivative. Okay, yes. Example is given. Root of x minus 1 by x plus 1. We have to show that f dash of x is 1 by x plus 1 into root of x square minus 1. Okay. Yes. So first you have to be, it is given as a, as what is the function? It is a quotient function. Okay, that is you have to do the quotient. First you have to do is, okay, steps has been given, and then you have to do the quotient rule, and which is in the u by form. So derivative of the denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. That equation is used here. Then simplify. And same according with respect to x, you have to differentiate the following equation using the above things, because absolute function, chain rule, okay, all should be used here. Next is the derivative of trigonometry function that you have now. Okay, you have studied in the previous class the t functions. Derivative of t functions has been there, and examples has been using, require the application of the chain rule. Here chain rule has been used. So differentiate the following with respect to x. Sec of tan x. Okay, the whole functions, and this is in your textbook. Okay, this is all textbooks problems has been there. You have to do all the workout examples. I am not giving you all the, in this chapter I am not giving you all that, but in the textbook there has been many problems which is workout. Okay, that is clearly given, the steps, the reasons, all are given for you. So these problems is very important, workout problems. If you solve these workout problems, then the exercise problems will be very easy for you. Okay, then that is given. First one is d by dx of sec of tan x. Sec of tan x. So two functions has been there. You have to use the product formula here. Okay, product formula here. That is sec of tan x into tan of tan x, which is 1 into d by dx of tan x. That is sec of tan x into tan of tan x into 6. Oh, that is not, which is very, yes, which is very confusing for you. So you have to use the convenient, which can be used as another formula. That is you have to take tan x as u, then you will get s. I think it is clear, but you have to take it as u, and du by dx is equal to sec square x. What is tan x? Tan x derivative sec square x. So du by dx is sec square x. Then d by dx of sec tan x is 1 d by dx of sec u. That is sec u. That is d by dx of sec u into du by dx. That is sec u tan u into sec square x. Then substitute the u function. Okay, that's next is also cos sin square, sin x square, cos of sin square, sin x square. Similarly, you can do this. Derivative of the first into derivative of the first function into derivative of the second plus second into function. That same has been used here also. Okay. Next is also root of 1 minus x plus 1 minus cos x plus 1 by sin x. This function, these functions derivatives, which is very important. Okay, please do this functions, which is given in the textbook also, which is given for you also. Okay, yes. Next is the differentiation of logarithmic and exponential function. Okay, you have to study these results, then you can apply the differential equations. Differential, okay, we can derive that and from using this equation or results. That is log to the base a of mn, or log mn to the base a is log m to the base a plus log n to the base a. Okay, the base is not pronouncing, we cannot read the base, you just read that. Log of mn is log of m plus log of n, and log of m by n is log of m minus log of n. Log of m raised to n is n log m, and log of m is log of m to the base a. It is log of m to the base b into log of b to the base a. Okay, or log of b to the base m is log of a to the base m by log of b to the base a. That is the base. And log of 1 is always 0, and log of a is always 1, and limit extends to infinity, x tends to 0. 1 plus x the whole raised to 1 by x is e. 1 plus x the whole raised to 1 by x is e. This equation is also using many there. And e raised to x by limit extends to infinity, e raised to x minus 1 by e is 1. It is the exponential functions. These three are the exponential function, and limit extends to infinity, a raised to x minus 1 by x is log a to the base e. Okay. Okay, if the log function is not, the base is not there, mentioning there, then it is e. Log to the base e, always the base is e. Okay. Next is the derivative of log of x to the base a, where a and x are positive and a not equal to 1. That is 1 by x, which is given. F of x is log of x to the base a. The derivative is 1 by x log 1 by x into 1 by log a to the base e. Okay, a small proof like that is given. Okay, the answer is 1 by x into 1 by log a. Okay, and derivative of log x when it is x, which is positive, log 1 by dx of log x to the base e is 1 by x. Always the derivative of log x is 1 by x. Okay, and derivative of log of modulus of x is 1 by x log a. 1 by x log a. It is the derivative of the modulus function. Log of the modulus function. D by dx of log of mod x is 1 by x log a to the base e. Which is, we cannot read it as, we can, it is not important to read e. Okay, yes, that is. Okay, that is, this is the, sorry, these are the derivative functions of the logarithmic function and the exponential function. Okay, so this is the, the main functions which is to be studied. Many problems, all the problems has been, the differentiation chapter is very lengthy because there are many workout problems for you, given for you. So you have to work out that problems very clearly, then you will understand all the derivatives. Okay, and you have to first recall these all equations. Okay, what is the derivative of that is this. Okay, that like that. So if you are very thoroughly understand that, thorough with that equation, then you can do any problems. Okay, there has been many problems are given for you. Please do that workout problems because I have no time. So I am very hurry in completing your your portion. So I have not able to give all the problems. Okay, so please understand and please cooperate with me, and if you feel any doubts in this chapter, please ask me. I have no issue in clarifying your doubts or anything. You can ask me anytime, or you can call me, or you can message me, anything. Okay, I will clear your doubts as I can. Okay, so please do all the problems and do the exercises and study very well. Okay, thank you students, have a nice day.